Hi guys, today we're going to be taking a look at our fourth conic, which is called a hyperbola. Okay, and like all the shapes, me explaining like what the shape is and the different how the equations look, that's going to be the hardest part of the lesson. And then once we get into just actually working through the problems, it'll probably go pretty quick for you. Okay, but first let me take a look at what's going on here. So this is an example of a hyperbola. If you've got these two branches that are going away from each other, I know they kind of look like a parabola. They're not, and I'll explain what makes this curve look different than a parabola in a second. A hyperbola has two sets of vertices. So these are the vertices of the hyperbola. For an ellipse, we had two sets. We had those major vertices and we had minor vertices. These just have one set of vertices. And you also have two foci, just like we had on an ellipse. We have a focal point over here. So again, if you are kind of picturing this like a parabola, the focal point is inside this curve and the shape is kind of curving around that focal point. And then you've got a mirror image over here that's doing the same thing. Okay, so our goal, one of our main goals today is just going to be to graph this. So we're going to find the center, we're going to find these vertices, and we're also going to find these foci, these focal points. Okay, now if you look over here, you're going to see a lot of the things we saw yesterday. You're going to see an A and a B, and you're going to see a C, and then when you look down at the equations, you're not going to find a C. So again, that's going to be a little mini formula. And this one is exactly like the Pythagorean theorem. So you've got c squared equals a squared plus b squared, where your a squared and your b squared are going to be the denominators of these two formulas over here. Okay? So there are two different ways the hyperbola can go. It can go side to side, or it can go up and down. So this right here probably looks a little bit like a parabola to you. It's kind of going in that vertical way that we're used to. But I also want you to notice all these little dotted lines here. Okay? So we've got these two diagonals, and these are asymptotes. And what they are, they're these imaginary boundary lines that our graph curves and then follows. Okay, it just gets closer and closer and closer and closer to those asymptotes. So if you look at this one, this is what makes this different from a parabola. A parabola curves and then eventually starts going really, really vertical and taking off this way. Well, a hyperbola doesn't do that. It follows this dotted line out towards infinity that way and out towards infinity that way, but it doesn't curve back up like a parabola does. Okay? So we've got two ways that this shape can look, and we've got two formulas. So let's take a look at the formulas down here. This looks exactly like the ellipse, except it has a minus in it. Okay? So think of this fraction as being like a positive, and then you have a negative over here. That's going to help us later on. Okay? So one of these is going to be negative, and that's what that minus is telling us. Now, if the x is the positive of the two fractions, then your hyperbola is going to be going in an x direction. Okay, so notice that this hyperbola is going to the left and it's going to the right, and that is being caused by that x right there. So this matches up with that picture. If the y is first, if you see the y being squared, the y is the positive. Now your hyperbola is going up and down, which is more of a y direction. Okay, so that's what's causing the graphs to look different from each other. It's which one you're seeing first. Now, when we graph these, when we graph a hyperbola, there's actually only 2 points we're going to graph. We're going to graph this vertex, we're going to graph that vertex, and that's the only points that are even on the hyperbola. The rest of the hyperbola is just going to curve up and follow this asymptote. It's going to curve down and follow this asymptote. Same over here, same over here. So we're going to have to draw those asymptotes. You may also notice there's this little box, okay, which I will usually just call a box, that we're going to draw. And the reason we're going to draw this box is because if you notice, the asymptote goes through the corners, so from corner to corner, and then towards infinity, it's going through this box, and then this one goes from corner to corner through the box. It goes through the center, and then it goes through these corners of the box. Okay, so what is the box? Well, that's what your a squared and your b squared are going to do. We are going to draw the exact same thing we drew yesterday. We're going to find our center. We're going to go up a certain amount. We're going to go down a certain amount. We're going to go left a certain amount. We're going to go right a certain amount. Those amounts are going to be controlled by the square roots of these two numbers, just like an ellipse. But then instead of drawing an ellipse, we're going to make this little imaginary invisible rectangle. We're going to draw that because then we're going to connect those corners to create our asymptotes. And then once we have the asymptotes, then we can just curve up and follow that dotted line, curl down, and that's what's going to give us the rest of the shape. Okay? What else are we going to do? We're going to find our vertices. There's only, so kind of like those major vertices, this is why we only did the major vertices for an ellipse. A hyperbola only has one set of vertices, so those are the ones we're going to list. We're also going to find our focal points, which are going to be further out than our vertices are. That's why we do a squared plus b squared. We're going to add these two together, which is going to create a bigger number. And then when we take the square root of that, we're going to be somewhere outside our vertices. And the last thing we're going to do is we're also going to say what these asymptotes are. Okay? So this is a line. There are two ways to talk about a line. You could use slope-intercept form, so y equals mx plus b, or you could use point-slope form. Well, for these two asymptotes both go through the same point, which is our center, and they both have slopes that are like opposite of each other. So like if this line is going up 3 over 2, this line is going down 3 over 2. So the easiest way we're going to write our equations would be to use, this is point slope form. This is a point, it's our HK, and then this is the slope of the two. One's going to be positive, one's going to be negative, but the number part of the slope is going to be the same. So we can just write plus minus our slope, and that one equation is going to label both of these asymptotes right here. Okay, so like I said, everything I've just talked about is literally the hardest part of this lesson. Once we turn the page and start looking at some actual examples, it'll make a little bit more sense to you, and it'll be a little bit easier as I walk you through it. Okay? All right, so let's take a look at our first example here. So here's my equation. I see the minus sign, so this is a hyperbola. The absolute very first thing I'm going to do is I'm going to notice that the x is first. So this is going to be a hyperbola that goes more like in the x direction. So I'm going to write that right away so I'm getting my brain going in the right direction. Okay? We are supposed to find the center, the vertices, the foci, and then this new thing, we're going to write the equation of the asymptotes. Okay? So, and then it says graph the equation. Well, that's what we're going to do first. We're going to graph the equation, and then we're going to pull this information off. Except for the center. Now, the center is easy. Same as everything else. Positive 3, negative 1. So that's our center. So I'm going to go right over 1, 2, 3, and then negative 1. All right. Now, when we looked at that hyperbola, there was a box, and then the asymptotes went through the box. Okay? So that's what I'm going to draw now. I'm going to draw the box. And I'm going to do it just like we did an ellipse. I'm going to move in the x direction, the square root of this number. So 4. So 1, 2, 3, 4. 1, 2, 3, 4. I'm going to move in the y direction, the square root of this. So 3. So go back to the center. 1, 2, 3. 1, 2, 3. Now, instead of connecting those in a curve, we're just going to make a rectangle out of them. So just pick a place to start. I like to start here on the top, and then I go over. So now I'm right above this point. So I'm going along the bottom, so I'll stop right here. So I'm right underneath that point. Okay, now make sure you make those dotted lines. This is not really part of the graph. This is a tool we're going to use to make the graph. Okay, now you could also use different colors. Like if you want to use a pencil for all this, and then if you want to use a pen and make the actual hyperbola darker, that'd be good, as long as you don't mess up, right? Okay, so the reason we drew the box is so that we could draw our asymptotes. So those are diagonal lines. They're going to go through the center, and they're going to pop out through the corners of this box. So this one is going to go directly this way and this way. So there's one asymptote. And there's another one that's going to go this way. Okay, those are our asymptotes. Now, remember, we said from the very beginning, this is the direction that our hyperbola is going to go. It's going to go side to side, which means these 2 points, these are the vertices of our hyperbola. Our hyperbola is going to go through this point. It's going to curve up and follow that asymptote and go, like, keep following it that way. It's going to curve down and keep following it that way. It's going to do the same thing over here and the same thing over here. So those two shapes, those consist of all the xy coordinates that would work in that equation. Okay, that's our hyperbola. Now, the top and the bottom of the box, that's just the top and the bottom of the box. Those aren't anything. Okay, so don't list these, don't label these. They're nothing. They're just part of the box to us. Okay, when I ask you for the vertices, I'm talking about these 2 points. Okay, the points that our graph actually goes through. So what is this? This is -1, -1. And then this other one is 7, -1. Sorry, I have to keep sliding back and forth. 7, -1. So those are our vertices. What else do they want? They want the foci. All right, foci. So this is that little mini formula. So c squared equals a squared plus b squared. So in this case, it's going to be 16 plus 9. So that's 25. Then we take the square root, and we get plus or minus 5. So for this one, the foci are going to be nice points. They're going to be 1, 2, 3, 4, 5 to the left. That is a focal point. And 1, 2, 3, 4, 5 to the right. That is a focal point. So for this, I can just list those 2 points. Okay, I can write this point. What is this? 8, 1, and -2, or -1. 8, -1, and -2, -1. So those are my foci. 8, -1, or what was it? -2, -1. Okay. We could have used that other, like the other method where you go to the center and then you add or subtract 5 in the x direction. And that's perfectly fine, but since these are nice ordered pairs, I'm just going to write them that way. Okay, so that's my foci. I'm also supposed to write the equation for my asymptotes. Asymptotes. Okay, now the equation for your asymptotes looks, let me write it up here. It's, when you learn the point slope form, it was y minus y1. Well, it's going to be y minus a y coordinate. Okay, so it's going to be y minus h, and then equals plus or minus m x minus, y minus k, and x minus h. Okay, so that's the formula we're going to use. But if you go back to the original equation, this parenthesis is x minus h. It's just being squared. And this parenthesis is y minus k. It's just being squared. So if we remove those squares, that's going to be our starting point. Because the point we use for point slope is this center point, which is what those two tell us. So I can tell you right now, the equation for our asymptotes is going to be y plus 1 equals, just don't put the square, it's not squared, these are lines, so y plus 1 equals, and then it's going to be plus or minus our slope, which we don't know yet, and then it's going to be the x minus 3. So the only thing I got to do is I got to figure out what the slope is. And I only need one of these slopes, because one of them is positive, the other one's negative, but they're both the same. So when you do slope, what do you need to know? You need to know the rise over the run. So take a look at this. You need 2 points. Look at the center, and then look at this upper corner. How do we move to go from here to here? You go up 1, 2, 3. You go over 1, 2, 3, 4. That's our slope. Up 3 over 4. The other one is down 3 or negative 3, but still over 4. So this one's positive 3/4. This one's negative 3/4. So there's our slope of our 2 lines, plus and minus 3/4. And that's it. That's how you write the equation of the asymptotes. Okay? All right. Let's look at the next one. Now, next one is not in standard form. So that's what our job is going to be. We're going to have to get this into standard form. So the first thing I'm going to do is I'm going to get my like variables together. Notice one of them is positive and one of the squared terms is negative. So this is going to be my second one. Okay, whenever we did circles or ellipses, we always did the x squared and the x first, then we did the y squared and the y. We're not going to do that. We're going to put the positive one first. So we're going to leave the 4y squared. We're going to put his buddy plus 24y. Leave a blank. We're going to put those first because they're positive. Then we're going to put the minus x squared. And then the plus 4x. We're going to leave a blank. And we're going to move the 28 to the other side. So negative 28. We're going to put a couple blanks over there. Now, just like the ellipse, we're going to factor. I can't complete the square. The y squared has to be by itself. So we're going to factor out a 4. Y squared plus, so what's that going to be? 4 goes into 24 6 times. 6y. We're going to leave a blank. Now, that x squared is not by itself. It has a negative 1 in front of it. So we're going to factor out a negative 1. So minus, and that's going to be the minus sign of the hyperbola. Okay? Now, we're factoring it from both of these. Don't make this mistake. This is going to be x squared, and now this is minus 4x. Equals, and then we still got the negative 28. We've got a blank, we've got a blank. All right, so now we're going to complete the square. So, in this our first line, we're going to take half of 6 is 3. 3 squared is 9. So that's what is going to go in that line. Remember, that 9 is being multiplied by that 4. So when I go to balance things, I'm going to put a plus 36 on the other side. Now we have to complete this square. So negative 4, half of negative 4 is negative 2. Negative 2 squared is 4, so we're going to put a plus 4. And then I am not going to put a plus 4 over here, because that 4 is being multiplied by the negative sign just like everything else is being multiplied by it. Okay, so what I really did was I added a negative 4 over here. So we're going to put a negative 4. Now we're all set. So let's see what I got. I've got 4. This is going to be y plus 3 squared minus, this is going to be x minus 2 squared equals, all right, I've got negative 28, I've also got a negative 4, so I have a negative 32 altogether, and I have a positive 36, so this is 4. And then just like the hyperbola, or just like the ellipse, we want this to equal 1. And we want to get our denominator so we can see which way we're supposed to move. So we're going to divide everything by 4. If I divide, so that gets divided by 4, that gets divided by 4, and so does that. So these 4's are going to cancel. Y plus 3 squared over 1. This is just going to stay the same. X minus 2 squared over 4 equals 1. It's a parenthesis. All right, so here is the equation of this hyperbola. So now we're supposed to go graph this. Okay, so again, what do we need? We need our center. Be careful. The center is 2. Remember, we have to look at the x value first, kind of like we did with the parabola. Okay, so make sure you find your x first. So it's going to be 2, negative 3. 2, negative 3. 2, 1, 2, 3. Oh, before we go any further, remember, the y is the one that's being squared, so this is going to be one that goes in the y direction. It's going to go up and it's going to go down. Okay, that's going to be important. We want to get our brain going in the right way. All right, that's our center. I am going to go, now I'm going to draw my invisible box. I'm going to go in the y direction, 1, because it's the square root of 1. Okay, so I'm going to go up 1, down 1. I'm going to go in the x direction, 2. 1, 2, 1, 2. I'm going to use those 4 dots to make my rectangle. I'm going to use the rectangle to figure out where my asymptotes go. And then I use the asymptotes to draw my curve because it's going to follow those asymptotes. Now remember, this one goes up and down. So I'm going to go to the top of the box, and I'm going to draw the top part of the hyperbola. And then I'm going to go to the bottom box, and I'm going to go draw the bottom part. So these are my vertices. These 2 little points, these are the only points that I actually have on the graph, but these are my vertices. So when I list my vertices, it's going to be this point, which is 2, negative 2. It's going to be this point, which is 2, negative 4. My foci are going to, again, they're going to be up and down. Okay, they have to be inside this curve, just like the parabola was. So, c squared equals a squared plus b squared. So what do I got? I got a 1 plus 4, so a 5. So c is plus or minus the square root of 5. So, what's that? 2.2, 2.3, somewhere in there. Okay, you can put it in your calculator if you want, but it's going to be a little bit more than 2, a little bit more than 2, so that's where our foci are. So this one we do have to use the other way of writing. So I went to my center, which was 2, negative 3, and then I added and subtracted to the y value. I went up and down, and the amount I went up and down was radical 5. So the foci is 2, comma, negative 3 plus or minus radical 5. And now I'm also supposed to write my asymptotes. Okay, so I need to draw this line. Well, this line goes through the center, so that's my point. So it's the y plus 3 equals, and then it's also going to be the x minus 2. I'm going to slide that over, x minus 2, because I'm going to put my slope here in the middle. So now I just got to figure out what the slope is. So again, look at this, go to your, sorry, video got cut off. So go to your center, and then figure out your slope. So up 1 over 2. So go from your center out to this corner. Up 1 over 2. So that's our slope, 1/2, 1 over 2. Okay, this other one is down 1 over 2. So negative 1 over 2. So there you go. Plus or minus 1 over 2. That one equation takes care of the equation of both of those asymptotes. Okay, so this one, I want you to try on your own to see if you can get it into standard form. So I'm going to pause this video, so I need you to pause it, see if you can get it into standard form, and then play. Make sure your standard form is right, then go and try to graph based off of the standard form. But don't try to graph it until you've checked the video and you've made sure that your standard form is right, or there's no way your graph's going to be right. Okay, so I'm going to pause this now. Okay, so this is the standard form you should have come up with. So if you got that, then great. So move on and see if you can now graph this. I will tell you there's going to be some weird values because you'll notice this is a perfect square, but this is not. So the amount you move in the y direction is not going to be a perfect square. So we're going to have to do some approximating. And it also means when we go to write our slope, for our asymptotes, it's also the amount we go up and over, we're going to have a radical in it. It's not going to be a nice, pretty slope. Okay? So again, if you did that, great, move on. If not, then you need to go through my steps and compare them to your steps and see what is it that you did wrong. Did you factor this 2 out from the very beginning? Did you factor this negative sign out from both of these? So notice I have a minus 4y instead of a plus 4y. Okay, then I completed the square. I put a +1 here to complete this square, but since that was being multiplied by a 2, I had to put a 2 over here. I completed the square here with a 4, but again, that's being multiplied by this negative sign, so it's actually a -4 that I had to put over there to balance things out. This all now factored into these nice perfect squares, and I ended up with a 2 over here, and so I had to divide everything by a 2. That 2 and that 2 canceled, leaving me with this 1. There was nothing here to cancel, so I just have a 2 there. Okay, so from there, I'm ready to graph it. Okay, so go back, see if you can see where you made a mistake, and try to fix that. Again, I'm going to pause this now, and then I'm going to graph it. So try to graph it on your own as much as you can. All right, well, I started graphing this, and then I'm going to just go ahead and finish it and walk you through it. So just look at my final picture. Hopefully yours looks like mine. So I found my center. Oh, first, I wrote down which way this is going to go. So this hyperbola is going to go in the x direction, side to side, and so I wanted to write that down first. I found my center. I went in the x direction 1. I went in the y direction radical 2, which is like 1.4. So I had to approximate, go up about 1.4, down about 1.4. That's how I drew my box. I then connected those diagonals to draw my asymptotes. So now I'm ready to draw my shape. My hyperbola goes side to side, so it's going to curl up. It's going to curl up and down. My vertices are going to be these 2 points that I actually went through. So what's this? -2, 2. And it looks like 0, 2. I need to find my foci, which again are going to be the square root of 1 plus 2, so radical 3. So that's how much I'm going to move. And again, I'm going to move left to right. So radical 3 is, I don't know, 1.7, 1.8, somewhere in there. Okay, so it's going to be a little bit over here, a little bit over here. But the important part is how I write it here. So I went to my center, and I added or subtracted radical 3 to the x value. So it's -1 plus or minus radical 3, comma, and I did not change the y value, so 2. And then I've got my asymptotes that I'm supposed to write. So again, it's y, so you got to do your y first. So y minus 2, and then what's my slope? I went up radical 2, and I went over 1. That's what that is. That's what that movement is. Up radical 2 over 1. And that's how I'm going to write it. I am not going to write 1.4 over 1. You cannot have a decimal in a fraction. You're never allowed to write numbers that way. Okay, so it's going to be plus or minus radical 2 over 1. Or just plain radical 2. That's fine. And then it's the x plus 1. All right, so that's your graph. That's all the information you should have got off that graph. So now take a look at your homework, see if you can do these, and we'll take a look at them later. Thanks.